As an introduction to rational functions, the first type of rational function I would like to look at is negative power functions, in particular the reciprocal function. So if you will, take a look here. We're on Desmos graphing here. I've got y equals 1 over x, which is really what? X to the negative 1 power, right? Okay, now this is the graph of it. You can see in here, this thing's technically called a hyperbola. And what I'm going to do here is go ahead and get a table of values for the function there. As you can see here, when x is negative 2, the value of the function is negative a half, as you can see here. When x is negative 1, the reciprocal is negative 1 also. How about 0? What's 1 divided by 0? Yeah, there's no such thing. It's undefined. 1 divided by 1 is 1, 1 divided by 2 is a half, 1 divided by 3 is a third, and so on and so forth here, as we can see. By the way, this function would have what? Because that's really x to the negative 1 power, and negative 1 is odd, this would have what kind of symmetry? Yes, origin symmetry, okay? And you can see it does indeed have origin symmetry here. What's the domain of that function? 1 over x. All real numbers except x equals 0, right? You can go ahead and get a value out of that function for all values of x when you plug that value of x in, except 0. You've got problems at 0. And in fact, let's look at a couple things here. What happens when x is approaching 0 from the positive side? So in other words, I'm going to imagine approaching 0 from the right, so I'm imagining very small values of x, okay? Very small values of x, but positive, okay? Now, what happens to the values of y, the reciprocal? Okay, what would we end up getting here? For example, let's see if I can plug this in here and see what you get. What if I had 1 divided by a tenth? 1/10 is my value of x. Well, the reciprocal of 1/10 is 10 over 1, or 10. So the actual point here would end up being all the way up here. Yeah, I'm getting what? I'm getting a large value of x as x approaches 0 from the positive side. What if it's instead, let's come over here and make a change. Let's make it 1/100th. Then the value of x is actually 100. So that's way up there on my scale, okay? Well, I'm not going to bother actually zooming out to get that particular point. But you can see what's happening here. What happens? As x approaches 0 from the positive side, the reciprocals, the y values, are approaching positive infinity. They get larger and larger and larger without bound, okay? Something similar is happening over on the left-hand side for negative values of x, only they're becoming very large in absolute value, but with a negative sign, right? So they're, as x approaches 0 from the left, or from the negative side, the y values are actually approaching negative infinity, okay? Now, let's consider another thing that's happening here. What's happening if as x approaches infinity itself? So let's say x gets larger and larger and it's positive. So x is 2, 4, 6, 8, 100, okay? You can see the values here. The value of the function is the reciprocal of the value of x. So I'm getting what? 1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/100th. Okay? What's happening to the y values as x gets large? They approach 0, right? They're approaching 0. And the same thing is happening on the other side when the values of x are approaching minus infinity. The values are getting small, only they're going to be what? Negative. Okay? So we would say the limit as x approaches infinity of f of x is equal to 0. The limit as x approaches minus infinity of our function here, 1 over x, is also 0, but they're approaching from two different directions, right? Okay, now this phenomenon where as x approaches 0 from the positive or negative side, let's say from the positive side, see how it's skyrocketing towards positive infinity? We say that this line here that it's approaching, you see it's approaching two different ways here, this vertical line y equals 0, or I'm sorry, x equals 0, is what we would call a vertical asymptote for this particular rational function, 1 over x. The horizontal line, y equals 0, which is really the x-axis, is what the function is approaching as what? X approaches plus or minus infinity, okay? So these two, the vertical line and the horizontal line, represent sort of extreme values of the function. They're not actually attained by the function itself, though, okay? But we'll be using that terminology more and more here, horizontal and vertical asymptotes, okay? Now, what if I was to come over here and consider this function, y equals negative 1 over x, okay? Let's put that on there. Well, you can see with that negative sign out front that this would just what? Take our original hyperbola and do what? Reflect it across the x-axis, right? Okay? Alrighty, so you can see that there. These two are indeed reflections of each other across the x-axis. Alright, let's take that off. What if I took the original and just doubled it, multiplied it by 2, so 2 over x instead? You can see what I'm doing is stretching by a factor of 2 in the y direction there, okay? So multiplying it by that positive constant, went ahead and just stretched it a little bit. Now I could actually combine these and put a negative 2 out front, and then that would do what? That would reflect it and stretch it, okay? All right, well, let's take that off there. I'm not interested in that anymore. Let's do something else. Let's talk about something that's kind of related here. Let's talk about y equals 1 over x minus 3. Do you see what I did here? I took my original function, 1 over x, and I replaced x by x minus 3. That's like what? That's a composition, right? And in fact, what is it? If you're replacing x by x minus 3, you'd actually be what? Shifting or translating the function 3 units. So that should be moved 3 units in the x direction. Let's go ahead and see if that holds there. Okay, let's put it on there. Get on there. There it is. Okay. Let's maybe take this table of values off here. We don't need that anymore. There we go. You can see that what? The black one, which is 1 over x minus 3, is actually the purple one, which is 1 over x, shifted over 3 units. In order to see that, here's something we want to do here. Let's put this up here. Let's look at y equals, or x equals 3 instead. And you guys see here, it looks like for this function, y equals 1 over x minus 3, x equals 3 is a vertical asymptote, right? X equals 3 is a vertical asymptote. In fact, we're going to see how to find the vertical asymptotes of a rational function that's at least been reduced is to take the denominator and set it to 0. Okay, take the denominator and set it to 0. You can see here from this function, 1 over x minus 3, its domain is all real numbers except 3, right? This is where we have this problem here, right? X equals 3. So if we're approaching 3 from the positive side for this function, it's skyrocketing towards minus infinity. If we approach 3 from the negative side here, it's plummeting towards minus infinity. Okay, but the function itself doesn't actually exist at x equals 3. What about a horizontal asymptote? Do you notice that, once again, let's maybe take this purple, the original, off here for a moment. Do you notice here that this function also has what? Has a horizontal asymptote being the x-axis, that is y equals 0, the set of all points x, y in the plane such that y is equal to 0. Yeah, it looks like what? As x gets larger and larger in absolute value, either direction here, the actual y values are approaching 0. Okay? Alrighty? Now, so there is an example where we've actually done what? We've actually did a shift, a translation in the horizontal direction. We found we also had to do what? We had to shift the vertical asymptote. Okay, so this is a vertical asymptote here is the original vertical asymptote shifted 3 units to the right. Or we just say what? Positive 3 units. Let's pull these off here. Let's do something slightly different. And let's go ahead and put the original back on. What am I doing here? Okay, let's compare these two. I took instead y equals 1 over x squared, right? Y equals 1 over x squared. So that's really x to the negative 2 power. Now, because negative 2 is even, this ought to have y-axis symmetry, which it does, as you can see. See the blue one there? It has y-axis symmetry. Okay? Now here's our original, the reciprocal function. Y equals 1 over x squared is always going to have what? Non-negative, in fact, positive values, because the square of any number is positive. The reciprocal of the square is also positive, right? Okay, so this is what you end up having here. You still have what is a vertical asymptote. You've still got the vertical asymptote being x equals 0, as you can see, even for this one. Yeah, what's the domain of 1 over x squared? All values of x except 0. Yep. You have problems when x is approaching 0. You're taking a number that's really close to 0 and dividing it into 1. This is where you get the, in this case, skyrocketing behavior because all the numbers are positive here. What happens if we go to 1 over x cubed, so that's x to the minus 3 power? Again, we're going to have a problem at x equals 0. The domain is all real numbers except 0. And you're going to get this skyrocketing behavior again. Okay? It looks a lot like 1 over x, but the numbers are actually growing faster in the case of 1 over x here. Okay? Well, anyways, take a look at this. Okay, they happen to intersect right there. We don't care about that, but that's a nice feature for Desmos. Okay, so y equals 1 over x cubed is going to have what? Exactly the same vertical asymptote. So that's going to be the y-axis, or x equals 0. It's also, you notice here that as x approaches plus or minus infinity, y is approaching 0, so it has the same horizontal asymptote. Now these particular functions, where I'm talking about basically negative exponents on x, constant multiples of this, and then shifts of them, these are going to be particularly important in our analyses of rational functions in general. Okay, so this should be good for an introduction to rational functions.